All right, here's our first video for chapter 10. You can see we're talking about circles. We have a lot of vocab to go over and make sure we understand and become familiar with. So first one is the actual definition of a circle. So go ahead and pause the video and write in that definition. A definition of a circle is all the points in a plane that are the same distance from a given point. So what that means, let me just move over here for a second and demonstrate. So here's a given point right there. Now if you go the same distance away, let's say I go this far in this direction, I go this far, and pretend these are all, let's say, an inch. Pretend that it's accurate. If I go this far away in any direction, you can see all those points. If I keep filling this in, of course it's not perfect, but you can see that all those points that are, let's say, an inch away from that center form a circle. So that's our definition of a circle. All right, so radius, I think you guys know what a radius is. We'll just draw this in. Radius goes from the center of the circle out to any edge. So you can draw a radius in anywhere in a circle. We label it with an R, typically a lowercase r. So that's the radius. The diameter goes from one edge to the other edge, and it passes through the center of the circle. So if I draw this in, this is a diameter. It does have to cross through the center of the circle. One thing to know is that if I take the radius and I multiply it by 2, so 2 times the radius, it will equal the diameter of any circle. All right, moving on to chord. I'm going to put that definition in here. All right, so pause this if you need to get that in there. The chord is, or a chord is, the distance from one point on the circle to another. And so that means to another point on the circle, but it does not go through the center. The diameter is going from one point on the circle to another point on the circle, but passes through the center of the circle. So if I were to draw in an example of a chord, it could look like this. Going from one point on a circle to another point on a circle, but see how this line does not pass through the center? So that is a chord. And you can draw chords anywhere. I could draw another one right here. There's another chord from one point to another point. I could draw one right here from one point to another point, as long as it's not passing through the center of the circle. Same thing with the diameter, and I know we said that with the radius. Your diameter you could draw anywhere. As long as it's passing through the center and going from one point on the circle to another point on the opposite edge, you have a diameter. All right, so concentric circles, we want to go ahead and fill in. These are two circles with the same center. So if you look at the picture, here's the center of the circle. This is the center for this inner circle, and it's the center for the outer circle. You can see the circles are not the same size. The radius would not be the same. The radius of the inner circle would look like this. The radius for the outer circle would look like that, going all the way out to the edge. So those radii are not the same. All right, then we have congruent circles. Congruent circles are two circles with the same radii. That means the radius is congruent in both circles. So let's say this is 3 centimeters. If the radius of this circle is also 3 centimeters, then that makes the circles congruent. Basically, all you have to do is worry about if the radius is the same length, and you will have congruent circles. All right, interior and exterior points. This is going to be pretty straightforward. Interior points are points on the inside of the circle. So I could plot or draw any points in here. And just one thing to note is that the distance from the center of the circle to any of these points is going to be less than the radius. So if you notice, the radius of the circle goes all the way to the edge, and so those interior points will all have a shorter distance than the radius. All right, exterior points, if I exterior means outside. So it's all these points, you could draw points on the outside of your circle. And then the thing to keep in mind here is that the distance is greater than the radius. So if I were to draw to the center of the circle, so the distance to the center, that is greater than the radius of the circle. So all of those distances are greater than the circle. So greater than the radius, because see, here's the radius, and all of those distances to the center would be greater than the radius. So let's go ahead and write those two in, and then the pictures will make sense. Alright, so for the interior points, the distance to the center is less than the radius. For your exterior points, the distance to the center is greater than, not the distance. You guys see my typo? I'll fix it. Alright, done. So for your exterior points, the distance to the center is greater than the radius. Alright, so a central angle is an angle where the vertex of the angle is at the center of the circle. So if I were to draw an angle in here, starting at the center, here I am drawing an angle. Do you see how the vertex where the two rays of your angle meet right here is at the center of the circle? That is a central angle. Alright, and then next we have an inscribed circle. So an inscribed circle has the vertex of the angle is on the circle. It's not at the center of the circle, it's on the circle. So for example, let's say I draw, here's the circle right there, and then I can draw an angle from there, and that is an inscribed angle, where the vertex is actually on the circle. A central angle, the vertex is at the center of the circle. Alright, so here are two formulas that we want to make sure we know. Area of a circle is pi r squared, where you use the radius, square it, multiply it by pi. The circumference of a circle is pi times d, so the diameter. Now, area of a circle, so here's a circle. Area of a circle, we're talking about all the area within the circle like that. Now, circumference of a circle, you can think of it like perimeter. It's basically if you were to take maybe a measuring tape or something that could bend and measure the distance all the way around the circle, that's what the circumference is. So it's the same idea as perimeter of any other shape that we've looked at. Circumference basically is the perimeter, but of a circle. Alright, so on this slide we're going to look at some definitions and theorems. This is the last slide of the intro video. Our first definition, it says the distance from the center of a circle to a chord is the measure of the perpendicular segment from the center to that chord. So that's pretty wordy. Let's talk about what that actually means. First, here's the center of the circle. And then it says that there's a chord. So I'm going to go ahead and draw a chord in. So from one circle edge to the other circle edge, we've got our endpoints here. It's just not passing through the center, so that's a chord. So we know that the distance, if we were to draw in a segment representing the distance from the center of the circle to where it hits the chord right here, that will always be perpendicular. So let's draw another one just to make sure this makes sense. So here's another circle. This one won't be as nice looking. You've got your center. Let's say I have a chord from here over to here. Now let's say I even drew, there's my center. I could draw in, let's say, a radius from the center. Basically, the shortest distance to the chord, if you're trying to figure out the distance from the center to the chord, right there, you could go all the way to the radius. That is going to be a 90-degree angle. The other thing that's going to happen is where it hits your chord, it does split it into two congruent segments. So you do get two congruent segments out of that. So if you're finding the distance from the center of the circle to the chord, you have perpendicular, so 90 degrees, and you also have these congruent segments. That's going to help us out in some of the examples. Oh, okay, well that's what the next theorem is. If a radius is perpendicular to a chord, then it bisects that chord. So let's draw that one in. So here's the center of our circle. Here's a chord, just somewhere in the circle. Now if the radius, that's kind of what I drew in this one over here. If the radius is perpendicular, so here's my radius, perpendicular means we're going to have that right angle, then it bisects the chord. So this segment will be congruent to this segment. So you have congruent segments of your chord, as long as you have that 90 degrees. Alright, our next theorem. If a radius of a circle bisects a chord that is not a diameter, then it is perpendicular to the chord. Alright, I feel like some of these are repetitive a little bit. So here's our center of a circle. So if the radius of the circle bisects a chord that is not a diameter, well, a chord's not a diameter. That was part of our definition of a chord, so I'll just draw this one in again. Here's our chord. And then the radius of the circle bisects it. If it bisects it, then it means that it's going to create that 90-degree angle. It will be perpendicular. Oh, if it bisects it, so if these are, that's what it's saying. So if you know that the radius is bisecting the chord, you get these congruent segments. Well, if these segments are congruent, that means that that is going to be a perpendicular angle. So they go kind of hand in hand. If you have a perpendicular angle, then that means you've got congruent segments. If you have congruent segments, that means you have a perpendicular angle. Alright, last one here. The perpendicular bisector of a chord passes through the center of a circle. So let's say that here's the center of our circle. Here's a chord right here. If I were to draw in the perpendicular bisector of this, so I need a line that's going to be perpendicular and it's going to bisect. So let's say I just draw in a line like this and then pretend that I drew that better and it went through the center of the circle. So perpendicular and then it bisects it. It will go through the center of your circle every time. Okay, so the more we use these vocab words and theorems and definitions, we'll become more familiar with all this. But it is a lot to make sure, keep looking over your notes and start memorizing or becoming very familiar with what all the different words mean.